Hi everyone, I'm Ishwantan, student of SVC Bangalore. My USN is 1V22 CS187. My branch is CSC. Subject is Computer Aided Engineering Drawing. Significance of Engineering Drawing, BAS Convention of Engineering Drawing, Freehand Sketching in Engineering Drawing and Scales. Introduction. Engineering drawing is a crucial tool for engineers in the design and manufacture process. It helps in communicating ideas, concepts, and specifications accurately. BIS convention and freehand sketching are important aspects of engineering drawing. Significance of engineering drawing. Engineering drawing serves as a universal language for engineers, enabling effective communication. It ensures accuracy and precision in the design and manufacturing process. It aids in visualizing and understanding complex engineering concepts. Importance of BIS conventions. BIS conventions provide a standardized format of engineering drawings. They ensure consistency and uniformity in the presentation of dimensions, symbols, and notations. BIS convention facilitate easy interpretation and understanding of drawings by engineers, manufacturers, and stakeholders. Dimensioning and tolerancing. BIS conventions define clear guidelines for dimensioning and tolerancing in engineering drawings. Accurate dimensioning helps in proper assembly and functioning of mechanical components. Tolerancing ensures that the manufactured parts meet the required specification and fit together correctly. Symbolism and notations. BIS convention establishes a set of symbols and notations for representing various elements in engineering drawings. Symbols help in identifying features, materials, process, and other important information. Notations provide additional details such as surface finish, material properties, and tolerance. Sectional views. BIS conventions specify the use of sectional views to represent internal details of a complex components. Sectional views aid in understanding the internal structure, dimensions, and relationships of parts. They enable designers to communicate design and intent and facilitate manufacturing process effectively. Isometric projection. Isometric projection is a widely used technique for representing three-dimensional objects on two-dimensional plane. BIS conventions provide guidelines for creating isometric drawings which offer a realistic view of an object. Isometric drawings aid in visualizing spatial understanding and effective communication of design ideas. Freehand sketching. Freehand sketching is a valuable skill for engineers to quickly convey ideas during the initial design phase. It allows for the exploration of multiple design options and promotes creativity. Freehand sketches are an effective means of communication between the engineers and clients, facilitating better understanding. Sketching techniques. Freehand sketching requires understanding basic sketching techniques like line quality, shading, and proportion. Sketches should be neat, clear, and representative of the intent design. Practice and refinement of sketching skills help in becoming proficient in conveying ideas through sketches. Benefits of freehand sketching. Freehand sketching enables rapid visualization and iteration of concepts. It helps in problem solving as engineers can quickly sketch and explore different solutions. Freehand sketches are cost effective and efficient means of communication during collaborative design process. Integration of freehand sketches. Freehand sketches can be integrated into formal engineering drawings to enhance clarity for and understanding. They can be used to annotate or highlight specific design details. Integration of freehand sketches with engineering drawings adds a personal touch and aids in effective communication. Digital sketching tools. With technological advancements, digital sketching tools have gained popularity in engineering design. Digital sketching tools offer advantages like flexibility, easier editing, and enhanced visualization. They allow for the integration of sketches into CAD models, streamlining the design processes. Introduction to scales in engineering drawing. Scales in engineering drawing are used to represent real-life objects and structures accurately on paper. They help in determining the size, dimensions, and proportions of various elements in a drawing. Scales are essential for precise communication and understanding among engineers, architects, and other professionals. And the definition of the scale is a ratio between the linear dimension of a drawn representation of an object and the actual object. Types of scales. Architectural scale. Used in architecture scale and construction drawing. It typically represents measurements in inches or feet. Engineering scale, also known as a civil scale. It is used in civil engineering and represents measurements in feet and dimensional inches. Metric scale. Based on the metric system, it represents measurements in the millimeters, centimeters, or meters. Commonly used scales. 1:1 scale represents objects in their actual size where 1 unit on the other drawing equals 1 unit in real life. 1:10 scale objects on the drawing are 1/10 of their actual size, meaning 1 unit on the drawing represents 10 units in the real life. 1:100 scale objects on the drawing are 1/100 of the actual size, where 1 unit on the drawing represents 100 units in the real life. Choosing the right scale. Consider the size of the drawing sheet and the level of detail required. Determine the largest and smallest dimensions of the object being drawn to select an appropriate scale. Consult industry standards or guidelines for the specific applications and projects. Thank you.